In the drying the membrane course, we recommended that the membrane was fully dried after the transfer step. Now, this recommendation may have come as a bit of a surprise or even a shock to some people, because we're normally taught never to let the membrane dry at all throughout the whole Western blot protocol. But actually, this step can help to improve protein retention on the membrane, which can help to improve detection sensitivity and give us more reliable and consistent results. For more information on this, please refer to that course. In order to move on to the blocking step, you will first need to rehydrate your membrane. If your membrane is nitrocellulose, you will simply need to soak it for 2 minutes in either TBS or PBS, depending on your chosen buffer system, to allow the pH to be balanced. However, if it is a PVDF membrane, you will first need to reactivate it in 100% methanol with gentle shaking for 1 minute. This is an important step because it allows the PVDF to become hydrophilic. You can then briefly rinse it in pure water to remove the methanol, and then, as with nitrocellulose, soak it for 2 minutes in TBS or PBS. After this rehydration, your membrane is ready for blocking. If you did not dry your membrane, all you need to do is soak it for 2 minutes in TBS or PBS with gentle agitation, and this will prepare it for the blocking step. Now let's take a look at why blocking is an essential part of the Western blot workflow. When we've transferred proteins over to the membrane, all around those proteins will be empty spaces where there is no protein. Because we've chosen the membrane for its high affinity to bind protein, that means that primary and secondary antibodies would bind nonspecifically to all of those empty spaces. Therefore, the empty spaces must be blocked prior to the addition of the antibodies. Typically, this is achieved by incubating the membrane in a dilute solution of non-sample protein, but it can also be achieved using protein-free blocking solutions. Without this step, the antibodies would bind all over the membrane rather than specifically to their intended targets, and this would cause very high background and very low specific signal. Efficient blocking will allow us to detect only specific binding of the antibodies to the proteins of interest. Ultimately, this will help increase the signal-to-noise ratio of the assay by reducing background, and this is why optimization of the blocking step is critical for the best Western blot results. Now we've discussed the importance of the blocking step, let's go over the options that you have for choosing a buffer system.